Hi guys, my name is Patrick, but you can call me 26. And what we're going to do today is we are going to do another question, and the question in question is going to be threesome. Classic, right? So you're given an integer array nums, and you're supposed to return all the triplets such that they add up to 0. You should not contain any duplicate triplets in your array, right? So what that looks like is this is our array, and the first thing we'd want to do in this question, you're going to use pointers to solve it. So we need to sort the array. That's the first thing we need to do, right? So we're going to sort the array, and this is what it's going to look like when it's sorted all the way from -4 to 2. And we can now proceed with our pointers, right? So we're going to have 3 pointers. It's going to be the current pointer that the number that we're currently on. Then we're going to have another pointer, which is going to be one number next to it, right? And then we're going to have another pointer at the very end, right? So with these 3, we're going to add them and see if they add up to the target. And based on that, we're going to adjust them, right? If the number is negative, we're going to move the left pointer. If the number is positive, we're going to move the right pointer, right? The left pointer up and the right pointer down, or left and right, depending on which pointer we're talking about, right? And we're going to have our results array, and we're going to keep track of the sum. So let's do it for this question and see what it looks like. So we have this case first, and we have the following, which is going to be -4 plus -1 plus 2, which adds up to -3. And in such a situation, because it's negative, we move the left pointer to the right? So we do that, and now we're going to have -4 plus -1 plus 2, which if we add them up is going to be still -3. And in such a situation, in actual fact, we should actually skip this, but I didn't do that. We should actually skip this because it's basically the same. It adds up to -3, so we move to the next one. So we come to the next one, and now we have -4 plus 0 plus 2, and if we add them together, they do add up to -2, and since it's -2, what we do is we move the left pointer to the right. So now we come and we have -4 plus 1 plus 2, and this adds up to negative, and this is going to be -1, and we seem to have run out of room because the right pointer is right next to us, so there's no room for expansion, so we can't get any triples that add up to 0 when you're considering -4, right? So we move the current to the next number, right? So we move that, and then we move the left pointer to the number after it, and we try to get triplets from that, right? So now we add, and what we're going to add is going to be -1 and -1 plus 2, and this one's actually add up to 0, and remember our target is 0. So we could put all this in our results array, right? So we put it in the results array. That's going to be -1, -1, 2. They add up to 0, so we put that as that. And when you get a result like that, because it's we don't want duplicates, and we have already gotten some values, we can now move the current to the next number, because since we're not copying any duplicates, we know that there is going to be no other triplicates that we can get with this combination, right? So that does not include duplicates, of course, and we repeat the process, and now we have a sum of, and the sum is going to be -1 plus 0 plus 2, which is going to be +1. And now because the number is positive, we move the right pointer down, right? We move the right pointer to the left, so we move it to the left, and now the sum is going to be -1 plus 0 plus 1, which is going to add up to 0. And now we have another candidate because the 3 add up to 0, so you can actually put it in our results. And now remember our target is 0, so we now have two arrays in our multidimensional results array, right? And now we can proceed because we've already found a triplet pair, triplets that match. We can now move on to the next number, and this is what it's going to be. The sum now is going to be 3. It's going to be 0 plus 1 plus 2. The sum is going to be 3. And 3 is greater than 0, and we have no more room to run because the left and the right pointer are right next to each other. And so now we have completed, and now we can return our results array, and our results array is going to be -1, -1, 2, and -1, 0, and 1. So basically that's what we do: keep track of the pointers, move them around, sort at the beginning so that you can use the pointers. It wouldn't make sense if you have pointers and you haven't sorted, then the numbers need to either increase, right, so that you can know which pointer to move, right? So basically let's put all this information into code. Let's get to it. So the very first thing we need to do is we could just have a sanity check, and this sanity check is going to be whether or not our nums array has at least 3 elements. For us to find 3 unique elements, it has to have at least 3 elements, right? So we say guard nums.count. The count here is going to be greater than or equal to 3, else, and we could come here and we say var result, spell it out. Result is going to be a multi-dimensional array of integers, and it's going to start off as empty, right? So do this else, else return result, right? So, and result currently is empty. So what that means is that if somebody gives an array that is either empty or the number of elements is less than 3, just return that, right? Now for the rest of it, we say for I in, and before we do that, we need to sort it, right? So let's sort it. So let's come here and we say let's sorted is just going to be nums dot sorted, right? Now we have an array called sorted of our numbers arranged from the smallest to the largest, right? And we look through, we say for I in, and we want to go from 0 all the way, from 0 all the way to, but not including, sorted dot count, right? So we get sorted dot count, and afterwards what we want to do here is we want to check, the first thing we could check is we want to skip over repeated elements, right? So if you have a -1 next to a -1, we just want to continue to the next number, right? Because you're not going to get unique triplets if the two numbers are, the numbers next to each other are, what are they called? Are not unique, right? So what we want to do is we would like to skip that, but there's only one possible fly in the ointment. That is if the first element is 0, right? So how we check it is we check if I is not equal to 0, right? We check the number before it, right? So we say come here and we say sorted, and we come and say I, and we check whether this is going to be the number before it, which is going to be I minus 1. I minus 1, okay. Give it equal space, come here, give it equal space. So we check that, and if this is the case, what we want to do, let's just close this, and we just want to continue, right? So if you have two numbers of the same, just skip and continue, right? And then we have our 2 pointers, var j. J is going to be the index after I plus 1. K is going to be at the other end. Var k is going to be I. Sorted dot count minus 1, right? So it's going to be on the other end, and then we look through, we say while j is less than k, what do we want to do? We want to get the sum, so we say let sum, and sum is just going to be sorted I plus sorted j plus sorted k. So we sum them up and check if they're equal to 0. If sum is going to be equal to 0, right? If the sum is going to be equal to 0, we just call our result, and to it we append an array of the 3 elements, right? So that's going to be sorted I, comma, sorted j, comma, sorted k. So we get all 3 of them like so. We append them to the result. Then we move j to the next element, right? The element on the left, right? So we say j plus equals 1. Move j to the next element like so. And we check while j is not on the right end, we also check that sorted j sorted, we check that the next number is we're not coming across duplicates, right? So if you do come across a duplicate, what you're supposed to do here is just increment j, right? So move 1. If you come across a duplicate, move 1, right? Now else, if we come here and we check this, so the sum, else if sum is negative, right? If the sum is negative, we move j, because you're moving j to a larger number, so we come here and say j plus equals 1, like so. Else, what do we do? Else, that means that sum is positive, right? What we do in such a situation is we just decrement k, right, to a smaller number, right? And at the end of all this, we're supposed to return a result, right? So regardless of what happens, let's come here. Where does this end? Okay, it's expecting this. So what we want to do is after the end of the while loop, we just want to come here and we say return. And what do we return? We return the result, right? So that is basically that. And what we'd like to do is put this through its spaces and see if it works. So we come here, get this, cut it, put it here, like so. And then afterwards, try it out for size. Let's try it out for size. Copy this. Try running it. Run, see whether it works. And see if it passes our test case. It's accepted with our test case. And if we submit it, we check whether or not it will be accepted. And the answer is that it is actually accepted. And okay, it's not one of the best options, but it's not one of the best performing, or rather the time is, this is in terms of time, right? But it works, right? Now let's talk about the time complexity and the space complexity. The time complexity is going to be O of n squared, and the reason for this is straightforward. When we sort the array, the complexity is going to be O of n log n, right? But then afterwards, we need to take, in our worst case scenario, we might have to take n minus 2 steps for every single element in the array, right? So we take n minus 2 steps, then we take n minus 3 steps, and so forth. If you multiply that, it's going to be something like n steps n times, right? Which is going to be about n squared, right? So it's going to be realistically n squared log n, and we could call that O of n log n, right? O of n by n, or O of n squared, right? For the time complexity. For the space complexity, it's going to be O of n because we do create the results array. And in our worst case scenario, the results array might contain everything in our array, right? So it's going to be O of n for the space complexity.